In May 2021, something unprecedented happened in the Florida Keys. Scientists opened boxes containing 2.4 million genetically modified mosquitoes and released them into the wild. Local residents were terrified. Environmental groups filed lawsuits. Protesters demanded the experiment be stopped immediately. But here's what nobody expected. 6 months later, the population of disease-carrying Aedes aegypti mosquitoes had collapsed by 96%. Areas that previously reported hundreds of dengue fever cases each year suddenly had zero. Malaria transmission, which had been creeping back into Florida for the first time in decades, completely disappeared. This wasn't luck. This was the result of the most controversial biological experiment in United States history. One that took 10 years to get approved and could change how we fight disease forever. By the end of this video, you'll understand how releasing millions of modified mosquitoes might be the key to eliminating malaria, dengue, and Zika worldwide, and why 3 other countries are already copying this exact approach. To understand why scientists chose such a radical solution, you need to know just how desperate the situation had become in Florida. The Aedes aegypti mosquito isn't just annoying, it's one of the world's most efficient disease vectors, capable of transmitting dengue fever, Zika virus, chikungunya, and yellow fever. In 2020 alone, Florida reported 847 cases of dengue fever, with the Florida Keys accounting for nearly 60% of all infections. That might not sound like much, but consider this. Dengue fever can cause internal bleeding, organ failure, and death. There's no specific treatment and no widely available vaccine. But the real crisis was what epidemiologists saw coming. Climate change was expanding the range of Aedes aegypti northward. Warmer temperatures meant these mosquitoes could survive year-round in areas where they previously died off in winter. Miami-Dade County was reporting its first locally transmitted Zika cases. Even more alarming, malaria, a disease that had been eliminated from the United States in 1951, was making a comeback. The economic impact was staggering. The Florida Department of Health was spending $2.7 billion annually on mosquito control and disease prevention. Tourism, Florida's $67 billion industry, was taking hits every time disease outbreaks made national news. Hotels in the Keys reported 30% cancellation rates during peak dengue season. Traditional control methods were failing spectacularly. Pesticide spraying was killing beneficial insects but barely denting mosquito populations. These mosquitoes had developed resistance to multiple insecticides. Worse, they breed in tiny amounts of water, a bottle cap, a flower pot, even the water that collects in a folded tarp. You can't spray every potential breeding site across 4,000 square miles of Florida coastline. That's when the Florida Keys Mosquito Control District made a decision that would change everything. They partnered with a British biotech company called Oxitec to try something that had never been attempted in the United States, releasing genetically modified mosquitoes to eliminate their own species. The Science Deep Dive. The science behind this project sounds like something from a science fiction movie, but it's based on a surprisingly simple principle. Use the mosquito's own biology against them. Here's how it works. Oxitec's scientists genetically modified male Aedes aegypti mosquitoes by inserting what they call a kill switch gene. This gene produces a protein that's lethal to mosquito development, but here's the crucial part. It only activates in the absence of a specific antibiotic called tetracycline. In the laboratory, these modified males are raised on food containing tetracycline, so they develop normally and survive to adulthood. But when they're released into the wild and mate with wild females, their offspring inherit the kill switch gene. Without tetracycline in their natural environment, the offspring die before reaching reproductive maturity. The elegance of this system is remarkable. Only female mosquitoes bite humans and spread disease. The modified males don't bite, they're just looking for mates. When they find wild females and reproduce, the resulting female offspring die as larvae. Male offspring that inherit the gene also carry it forward, continuing the population suppression for multiple generations. Dr. Nathan Rose, Oxitec's head of regulatory affairs, explained it this way. We're essentially hijacking the mosquito's reproductive system to make it self-destruct. Each modified male can mate with multiple wild females, and each mating event removes potential disease vectors from the population. The numbers are staggering. A single modified male mosquito can mate with up to 10 wild females during its 2-week lifespan. If each female would normally produce 100 offspring, that's 1,000 potential mosquitoes eliminated by one modified male. Scale that up to 2.4 million modified males, and you're looking at the potential elimination of 2.4 billion disease-carrying mosquitoes. But the most impressive part isn't the kill switch, it's the targeting precision. The genetic modification is species-specific. It only affects Aedes aegypti mosquitoes. Other mosquito species, beneficial insects like bees and butterflies, and all other wildlife remain completely unaffected. The modified mosquitoes also carry a fluorescent marker gene that makes them glow under special light. This allows researchers to track exactly where they go, how long they survive, and whether they're successfully mating with wild populations. Every aspect of the experiment can be monitored in real time. Oxitec spent 15 years perfecting this technology. They conducted successful trials in the Cayman Islands, where Aedes aegypti populations dropped by 96% in treated areas. Similar trials in Brazil showed 95% population suppression. Panama reported a 98% reduction in disease transmission after releasing modified mosquitoes. The science was solid. The results were consistent. But getting approval to release genetically modified organisms in the United States would prove to be the biggest challenge of all. Controversy and approval process. The road to approval was a decade-long battle that revealed deep divisions about genetic engineering, environmental safety, and who gets to make decisions about public health. The first application to the FDA was submitted in 2011. What followed was the most rigorous review process for a genetically modified organism in U.S. history. The FDA required extensive environmental impact studies, toxicology reports, and efficacy data. They analyzed potential risks to human health, impacts on non-target species, and long-term ecological effects. Environmental groups were not convinced. The Florida Keys Environmental Coalition filed multiple lawsuits, arguing that releasing genetically modified mosquitoes could have unforeseen consequences. Their concerns weren't entirely unreasonable. What if the modified genes somehow transferred to other species? What if eliminating Aedes aegypti created an ecological niche that an even worse species could fill? Dr. J.D. Hansen from the Center for Food Safety testified before Congress. We're talking about releasing millions of genetically modified organisms into the environment, with no way to recall them if something goes wrong. This isn't a laboratory experiment, this is permanent environmental modification. Local residents were split. Many supported anything that might reduce disease risk and eliminate the need for pesticide spraying. Others worried about being guinea pigs in an untested experiment. Town halls in Key Largo and Islamorada became heated debates about science, risk, and community consent. The breakthrough came in 2020 when the EPA finally granted experimental use permits, followed by FDA approval for the first field trial. But approval came with strict conditions. Releases could only happen in specific areas of the Keys, population monitoring was mandatory, and the experiment could be halted immediately if any negative effects were detected. Even then, controversy continued. In November 2020, residents of Monroe County voted in a non-binding referendum opposing the mosquito releases. The vote was close, 51% against, 49% in favor, but it highlighted the community divisions that persisted even after federal approval. Oxitec and the Florida Keys Mosquito Control District pressed ahead, arguing that the potential benefits far outweighed theoretical risks. Dr. Andrea Leal, executive director of the Mosquito Control District, put it bluntly, "We're losing the war against mosquito-borne disease with conventional methods. We can't spray our way out of this problem. We need new tools. And this is the most promising technology we've ever seen." Results: and global impact. The results exceeded even the most optimistic projections. Within 6 months of the first releases in May 2021, monitoring traps showed a 96% reduction in Aedes aegypti populations in treated areas. More importantly, disease transmission plummeted. The Florida Department of Health reported 0 locally transmitted cases of dengue fever in the Keys during the 2021 season, the first time in over a decade. Zika virus surveillance detected no local transmission. Areas that had required weekly pesticide spraying suddenly needed no chemical intervention at all. Dr. Catherine Persinski, who led the monitoring effort, described the transformation. We went from catching 50 to 100 Aedes aegypti mosquitoes per trap per week to catching 2 to 3. The population collapse was faster and more complete than our models predicted. The economic impact was immediate. The Monroe County Tourism Development Council reported a 15% increase in bookings for the 2022 season, with many visitors specifically citing reduced disease risk as a factor in choosing the Keys. Local businesses that had struggled with outdoor dining due to mosquito problems suddenly found their patios usable year-round. But the real significance became clear when other countries took notice. Brazil, which had been conducting its own Oxitec trials, announced plans to scale up releases to cover 50 million people across 5 states. The Brazilian results were even more dramatic. A 77% reduction in dengue fever cases in treated areas compared to untreated control zones. Panama approved releases in 3 provinces where dengue fever had been endemic for decades. Within 18 months, they reported a 98% reduction in disease transmission. The Panamanian Ministry of Health calculated that the mosquito releases prevented an estimated 12,000 dengue cases and saved $45 million in healthcare costs. Indonesia, facing its worst dengue outbreak in history, fast-tracked approval for modified mosquito releases in Jakarta and Yogyakarta. Early results showed promise, with 85% population suppression in the first 6 months. The World Health Organization, initially cautious about genetically modified mosquitoes, issued new guidelines in 2022 supporting their use in areas where conventional control methods had failed. Dr. Raman Velayudhan, WHO's vector control specialist, stated, "The evidence from multiple countries now shows that genetically modified mosquitoes can be a safe and effective tool for disease prevention. We're seeing consistent results across different climates and ecosystems." Perhaps most significantly, the success in Florida opened doors for tackling malaria in Africa. The Gates Foundation announced a $50 million investment to adapt Oxitec's technology for Anopheles mosquitoes, which transmit malaria. If successful, this could prevent millions of deaths annually in sub-Saharan Africa. The technology is also being adapted for other disease vectors. Oxitec is developing modified versions of mosquitoes that transmit yellow fever, chikungunya, and even the Asian tiger mosquito that's spreading across Europe and North America. By 2024, genetically modified mosquitoes were being released in 12 countries across 4 continents. The total area under protection exceeded 100,000 square miles, covering populations of over 200 million people. Conclusion and future implications. From a controversial experiment in the Florida Keys to a global disease prevention strategy, genetically modified mosquitoes have proven that sometimes the most radical solutions are the most effective. The implications extend far beyond mosquito control. This success has accelerated research into genetic approaches for controlling agricultural pests, invasive species, and other disease vectors. We're entering an era where we can use biology itself as a precision tool for solving environmental and health challenges. But perhaps the most important lesson from Florida is about the balance between caution and action. Yes, genetic modification carries risks that must be carefully evaluated, but so does inaction when facing diseases that kill hundreds of thousands of people annually. What do you think? Should we be using genetic engineering more aggressively to fight disease and environmental problems? Or are we moving too fast with technologies we don't fully understand? Let me know in the comments below. And if this story of turning science fiction into reality fascinated you, Make sure to subscribe and hit the notification bell. We're exploring more breakthrough technologies that are quietly changing our world, and you won't want to miss what's coming next.